Hello dear students, welcome to the session and welcome to my newly launched EdTech startup and Thrive the Learning app. In the previous session, I discussed about resistance. In this session, I am going to continue the same part, that is basic electrical elements. Today, we'll discuss the effect of temperature on resistance and then we'll discuss inductance. So before starting the session, here is a small introduction about me. Myself, Mayank Kumar. I am your educator and founder of this app. I have the teaching experience of 4 years. I have the industrial experience of 1 year. I have worked in a renowned public sector undertaking company under the Government of India, that is Energy Efficiency Services Limited. I have done masters in electrical engineering from NIT Patna. I have qualified GATE 8 number of times and also cleared PSU exam. I have mentored more than 10,000 students. My areas of expertise are network theory, power electronics, power systems, electrical machines and control systems. So dear students, let's begin the session. Temperature variation of resistance. If you are changing the temperature, suppose you have a copper wire having resistance 4 ohm. Suppose it is kept at a temperature of 30 degrees Celsius. Now, if you bring this copper wire to another room where the temperature is 80 degrees Celsius. So what will happen? Its resistance will change, or even if you decrease the room temperature, there also resistance value will change. In fact, resistivity of the material is changing and hence resistance is changing. So let us see how it changes. With the change in temperature, the resistivity of material as well as the resistance is changing. Now, if we try to relate the change with mathematical expression, so the relation of variation of resistivity and resistance with change in temperature is given by rho equal to rho naught into 1 plus alpha delta T. I'll write all the terms, that is what is alpha, delta T, rho and rho naught. You are already know about rho. What is rho? It is resistivity. Next, if resistivity is changing, then and hence resistance will also be changed in the similar way, because if you multiply here by L by A, here if you multiply L by A, so it will simply become resistance. So you must remember these two relations, that is rho equal to rho naught into 1 plus alpha T and R equal to R naught into 1 plus alpha delta T. Now let us write all the things. Del T. Del T is equal to T2 minus T1. T2 minus T1, that is change in temperature. What is T2 and what is T1? T1 is initial temperature. T1 is initial temperature and T2 is final temperature, and T2 is, if you write T2, it is final temperature. You have initial temperature and final temperature. Clear? And note this point. T2 is greater than T1. T2 is greater than T1. That means temperature is increasing. What is R naught? R naught is resistance at temperature T1. That means resistance, the value of resistance at initial temperature. What is R? R is resistance. R is resistance at T2 temperature. This is T2. Clear? Now what is alpha? Alpha is very important term here. It is temperature coefficient of resistance. Now let us calculate the unit of alpha. So what is the unit of del T? It is change in temperature. So its unit may be Fahrenheit, Kelvin. So its unit is degree Celsius. Now what is 1? 1 is the constant term. So what should be alpha into delta T? alpha into delta t should also be constant. Now what does it mean? If delta t is constant, its unit is, delta t is not constant, its unit is degree Celsius. Now what about alpha? To make it constant, it should be per degree Celsius. It should be per degree Celsius. So its unit is per degree Celsius. The unit of temperature coefficient of resistance is per degree Celsius. Now what will happen? Suppose alpha is positive. Suppose alpha is positive. Once alpha is positive, so what will happen? If del T, I have already written T2 greater than T1. Why I am writing T2 greater than T1? This thing I will explain through one question. If alpha is positive, del T is positive, so this total term will be greater than 1. Greater than 1 means R will become greater than equal to R naught. R will become greater than R naught. It means if alpha is positive, then resistance increases. If alpha is positive, then resistance increases. Now in the case if alpha is negative, then resistance will be decreased. Now resistance will be decreased. Now what about the conductor? If you have a conductor, so for conductor alpha is positive. For conductor alpha is positive. Alpha is positive means resistance will increase if temperature increases. This is for conductor only. There are different materials. Suppose Hg, mercury Hg. For Hg what happens? Up to the temperature of 4.2 Kelvin, up to the temperature of 4.2 Kelvin, it is behaving like a zero resistance. It has negligible resistance. And after 4.2 Kelvin temperature, its resistance increases linearly. This is the behavior of mercury Hg. So different materials have different behaviors. Now here I am concentrating on conductor. Conductor what happens? Suppose this is the conductor. Now if temperature is increasing, so what happened? The atoms which are present in the conductor, the vibration of atoms increases. Vibration of atoms increases. If the vibration of atoms are increasing, and how current flows? Current flows means if electron is flowing, if electron is traveling, then there is current. Now what happens? Because of the vibration of conductor due to increase in temperature, because of increased vibration of conductor, this electron will face more resistance. This electron's movement, the speed of electron will be decreased. If its speed of electron decreases, if temperature is increased, speed of electrons decreases, and if speed of electrons decreases, that means current decreases. If current is decreasing, that means you can say resistance is increasing. This is very much important question for the point of interview. If your interviewer asking why resistance increases with temperature in conductor, if you say the simple answer alpha is positive, they won't accept. You will have to tell the actual reason. So this is the main reason why resistance increasing for conductor. Clear? So now let us solve two numerical questions. There I'll tell you where you people can do one mistake. That's why I'm writing T2 greater than T1 in this expression. See the first question on the board. A wire has a resistance of 10 ohm at a temperature of 30 degrees Celsius. If material has temperature coefficient of resistance equal to 0.01 degrees Celsius, then the value of resistance of the wire at a temperature of 70 degrees Celsius will be. Now if you solve the questions in examination, so you have to solve like this. Write all the terms given that what is given, the wire has resistance of 10 ohm. That means initial resistance of the wire is given, it is 10 ohm at a temperature of T1 30 degree Celsius. That means T1 equal to 30 degree Celsius. Now, material has temperature coefficient of resistance alpha equal to 0.01 per degree Celsius. 0.01 per degree Celsius. Now, you have to calculate the resistance of wire at temperature of 70 degrees Celsius. That means T2 is given, T2 is 70 degree Celsius. T2 is 70 degree Celsius. So how will you calculate? We know that you will write like this. We know that R equal to R naught into 1 plus alpha delta. Clear? Now if you write delta T, it will be equal to T2 minus T1. That means here it is 70 degree Celsius minus 30 degree Celsius. That means it is coming 40 degree Celsius. Clear? So now you write R equal to R naught, that is 10 into 1 plus 0.01 into 40. Now what will become? It will become 10 into 1 plus 0.4. If you are writing semester exam, so write like this. Don't follow any shortcut. Don't apply any shortcut. This is 14 ohm. So the answer is 14 ohm. This is the value of resistance, that is new resistance, that is 14 ohm. I hope it is clear to you. Now next move to next question, and here I will show where you people are doing the mistake. So just focus on this question. Now it is given the wire has resistance of 14 ohm at a temperature of 70 degree Celsius. So where you people are doing the mistake, I am telling you your mistake. Your mistake. Where you people are doing the mistake. You will write R naught equal to 14. Next you will write T1 equal to 70. Next you will write alpha equal to 0.01. Next you will write T2 equal to 30. Okay, 30 degrees Celsius. This is 70. And then you will write R equal to R naught into 1 plus alpha T delta T. From here you will write R naught you will write 14 into 1 plus alpha. Alpha is 0.01 into T2 minus T1, that means 30 minus 40. So here from here it will become 1 plus 0.6, 1 plus 0.6, 30 minus 70 it is, 70 it is. So from here you write 8.4. So this is wrong solution. This is a wrong solution. Why? Just before what you calculated, initial resistance was 10 ohm, temperature was 30. When the temperature is changes to 70, its value is coming 14 ohm. So here if initial resistance is 14 ohm, what should be the value of final resistance at the temperature of 30 degrees Celsius? Its value should be 10 ohm. But here you are getting 8.4 ohm. So this is your wrong approach. That is the reason why I written this question. And why I written T2 greater than T1. Here this resistance is given for higher temperature. So first read the complete question. The final temperature is 30 degrees Celsius. So it will be T1. It will be T2. If it is T2, then it is R. And what you have to find? You have to find R naught. You have to find R naught. So here you apply the formula R equal to R naught into 1 plus alpha delta T. Now what will you write? R is given to you 14. It is equal to R naught you have to calculate into 1 plus alpha. Alpha is 0.01 into delta T. 70 minus 30. Always delta T will be positive. So it will be 40. It will be 40. From here 14 is coming equal to 1.4 R naught. From here what is the value? It is equal to 10 ohm. It is equal to 10 ohm. So don't do any mistakes. Your final answer is 10 ohm. In fact, when I was in BTech, so once I did this mistake, and if you do any mistake, So from next time you will remember, you will means right now from then onwards, whenever I explain the temperature coefficient of resistance to students, so I do explain this type of question. That means first temperature is more, then temperature is decreased. I hope it is clear to you. Next is inductance. It's very important topic. Here we'll also discuss why inductor does not allow sudden change in current, and that is very much helpful for interview purpose also. So what is inductance? It is the property of electrical material that opposes change in current. What about resistance? Resistance opposes current. Resistance resistance opposes flow of current. Clear? Resistance opposes flow of current. What is inductance? It is opposing change in current. See the difference between flow of current opposition and change in current opposition. What is change in current? Suppose the current through a material was 2 ampere. Okay. Now with some arrangement in the circuit, if you trying to change the current to 4 ampere, so if there is inductor will oppose this change, and then it will take some time to reach the current from 2 ampere to 4 ampere. Clear? If there is simply resistance, so resistance is very innocent person. It's very innocent child. If it is 10 volt, it is 2 ohm, current will be 5 ampere. Right now if you change to 20 volt, the moment you change it to 20 volt, the current will become 20 by 2, that is 10 ampere. So resistance opposes flow of current, but it does not oppose change in current. That is the basic difference between inductance and resistance. I hope it is clear to you. Its unit is Henry, the name of scientist. Let us discuss inductor. What is inductor? So here, inductor is an electric element that stores energy in presence of electric field. Now the concept of electric field is coming. If there is magnetic field, then inductor will store energy in presence of it. So the stored energy by the inductor will be called what? It will be called magnetic energy. Why? Because it is energy storing the energy in presence of magnetic field. Next, it is the kinetic form. This is very important point. It is the kinetic form of energy. Why? Because it has been stored because of due to motion of charged particles. It is kinetic form of energy because it has been stored due to motion of charged particles. That means you have the charged particles. If these particles are moving, then there will be current. And since this energy is because of current, so that's why we are saying it kinetic form of energy. Its formula is, later on we will derive the formula. Right now you can note this formula, 1 by 2 Li square, and it is similar to 1 by 2 mv square. This was the kinetic energy which you studied in physics. Clear? This is 1 by 2 Li square. Energy stored by inductor. Clear? Next, I am telling you one point here, that inductor stores current. Inductor stores current. What does it mean? Actually, if there is current in a wire, like this, so what you will find? You will find that there will be magnetic field lines around the wire, and that will be circulating lines. That means there will be magnetic field lines like this. If there is current, there will be magnetic field lines. Hence, hence, if there is magnetic, if there is magnetic field line, then there will be current. If there is magnetic field line, there will be current. I hope it is clear to you. So if it is storing magnetic field energy, that means it will store current. Then it will store current. Clear? So next, let us see what is means how to form an inductor. Inductor is nothing but a coil. Suppose you have a frame. Suppose this is the frame. If you start wounding the wire like this, so that will become an inductor, just like a spring, just like a spring. But the difference is that a spring, you will always see that a spring is mounted on a very hollow surface. Okay, that means there is nothing. But in the case of inductor, there will be two types of inductor. One is air core, one is air core inductor, and another one will be iron core inductor. What does it mean? It means if coil is placed on some frame like this on iron material, then that will be your iron core inductor, and if the coil is simply placed like this will be called air core inductor. Now what happens? You are going to connect a battery. You got an inductor, you connect a battery. Let's connect battery. The moment you connect a battery, it tries to push a current I. Suppose this was very new inductor. Your professor purchased this inductor just one day back in the laboratory, and today at 10 am you enter to the lab. You enter to the lab to do the experiment on inductor. You take the inductor, you have the battery, you connect the battery, you switch on at 10 am. So now what happens? You will find that at 10 am the current through inductor will be 0. What does it mean? You might be surprised. This voltage source is trying to push a current I, but this inductor is not ready to take the current. What is the reason? Reason is that I am telling you, later on you will observe that the growth of current will start, and after some time there will be current I. Now what will happen if there will be some current I? So you will find the magnetic field lines like this. If there is some current I, you will find magnetic field lines like this. This is the magnetic field lines. Why magnetic field lines? Because if there is electric current in the wire, there will be magnetic field. So here wire is wound like coil. So in coil, if current is flowing like this, then your thumb will point the direction of north pole. Then the thumb will point the direction of north pole of the magnet. So this is north pole, this is south pole. So what happens at t equal to 0 means at 10 am, the moment you switch on the supply, magnetic field lines was 0. So what happens? The magnetic field lines development will start and it will become 1, 2, 3. That means number of field lines will be increasing. Once the number of field lines will be increasing, the same order inductor will be taking electric current from the supply. If number of field lines 0, current taken by the inductor is 0. Even if you connect 1000 ampere of source across the inductor won't take current the moment you connect the supply, because magnetic field lines are 0. So please note this point. Very important point, because when somebody asks you why inductor does not allow sudden change in current, you will have to tell this reason. What is the reason? Development of magnetic field lines is gradual process. Hence inductor does not allow sudden change in current. Hence inductor does not allow sudden change in current. Why? Because development of magnetic field lines is a gradual process. Now what kind of question will come into your mind? You will ask, sir, suppose inductor is carrying a 10 ampere of current. Suppose inductor is carrying a current of 10 ampere. So now tell me what will happen if we try to change the current to 20 ampere. So what will happen? Suppose for 10 ampere of current, it has 100 filled lines. It has 100 filled lines. So now for 20 ampere of current, it should have how much? It should have 200 filled lines. So what will happen that if you try to change the current from 10 to 20 ampere by changing the magnitude of the battery, this inductor will not accept sudden change in current. It will take some time. It will take some time for the magnetic field to come from 100 to 200. Clear? Now your question will be, sir, what will happen if I try to change the current to 5 ampere? 10 to 5 ampere, you trying to jump directly to 5 ampere. For 5 ampere of current, there should be 50 field lines. There should be 50 field lines. So that is also not possible suddenly. Why? If there are 100 field lines, so if current decreases, number of field lines will decrease. So it will also take some time. If it is taking some time, so inductor is not allowing the decrease in current suddenly. So this is the property of inductor. I hope it is clear to you. Next, calculation of inductance. So how to calculate inductance? Suppose this is the core. You start wounding the wires like this. Place the wires like this. This is the way to place the wire. Clear? Now if you place the wire, so now what happens? If you place the wire like this, that means one turn, two turn, three turn. That means one turn, second turn, third turn, fourth turn, fifth turn. Similarly, it will have n number of turns. N number of turns. Clear? It will have n number of turns. Next, this is the cross section. This is the cross section. So if you find area, its area will be A. It will be equal to pi r square if r is the radius, or if diameter is given to you, then pi d square by 4. This is what? This is area of cross section. This is area of cross section. This is area of cross section. Clear? This is area of cross section. Next important thing is L. L is the length. Next important thing is L. L is length. Length of what? Length of this frame. This is what? This is nothing but frame on which wires are placed. So L is what? L is length of frame. Clear? So now if you calculate inductance, inductance of the coil is given by the formula L equal to mu n square A by L. Mu n square A by L. N I have already explained, A I have already explained, L I have already explained. So which term is left? The left term is mu. So what is mu? Mu is permeability. Mu is permeability. So what is permeability? And its unit is Henry per meter. Its unit is Henry per meter. It is permeability. Now you write mu equal to mu naught into mu r. What is mu naught? Mu naught is permeability of free space. It is permeability. It is permeability of free space. What is its value? Its value is very much important. 4 pi into 10 to the power minus 7 Henry per meter. Its value is 4 pi into 10 to the power minus 7 Henry per meter. This is mu naught. Now what is mu r? Mu r is called relative permittivity. Relative permeability. Mu r is relative permeability. So what is relative permeability? Relative permeability means right now mu naught is the permeability of free space. So now if you are changing the medium, suppose you are taking iron. So iron will have some different permeability. So now instead of writing the value of permeability, we are defining a term relative permeability. What it will tell? Suppose permeability of iron is 250 times greater than that of air or free space. So you will write mu r equal to 250, mu naught equal to 4 pi into 10 to the power minus 7. Your permeability will become 250 into 4 pi into 10 to the power minus 7. Now what is the actual significance of permeability? It describes the property of magnetization. It describes property of magnetization. Property of magnetization of material. Property of magnetization. Clear? I hope it is clear to you. Now, what you people are confusing, if they give you question, numerical question, it will simply say the length. They are giving you two types of length. One, suppose they will give you the wire is 10 meter long. Length of wire is 10 meter. So here length of wire is not important for calculation of inductance. Length of wire was important for resistance. So here they are giving you length of wire. Don't confuse. Ignore that term. If they are giving you length of frame or simply say length of coil, this is the coil only, na? So this is effective length of coil, so that is called L here. Clear? They are asking you area of wire, so area of wire can't be calculated from the formula of inductance, because A means area of cross section of frame. Clear? So now let us have a question. Inductance of an iron core inductor is 2 Henry. Given that L1 equal to 2 Henry. Clear? If the length of wire is doubled, then the value of new inductance will be. They are saying that if length of wire is doubled means you can say L2 becomes 2 L1. This is length of wire, not the length of frame. Remember this point. Then the value of new inductance will be. So what do you know? L equal to mu n square A divided by L. Clear? Now what do you know? They are not doing any changes to this one. Area of cross section and length of frame both are fixed. Now length of wire is doubled. What does it mean? Suppose the length of wire is 1 meter. So for 1 meter and the length of frame is fixed. So for 1 meter, suppose you are placing the wire like this. Suppose it has 50 turns. Now what happens? You are increasing the length twice. If instead of 1 it was for 1 meter. Now if you are taking 2 meter of wire, so what will happen? Again the length of frame is fixed. So what will happen? The wire's turns will be closer to each other and hence number of turns will be doubled. So you can say that here the number of turns is 100. Here the number of turns are 100. Clear? So it means what? It means you can say that if L2 equal to 2 L1, it means you can say that from here you can write N2 equal to 2 N1. N2 equal to 2 N1. So now since L is proportional to N square, it means L2 become how much? 2 N1 means 2 square. 2 square 4. So it will be 4 L1. Clear? 4 L1. So 4 L1 means 4 into 2 equal to 8 Henry. This was very important question and it was very easy question. This question, why I given this question, why I discussed this question, just because to focus on the N, A and L. Clear? So this is your answer, that is 8 Henry. Now come to second question. It is saying a coil is wound on a cylindrical surface having cross-sectional area of 4 cm square and length of 3 cm. If the coil has 150 number of turns, the value of inductance of the coil is. So what will you write? You write given that what is given? Area of cross section of frame 4 centimeter square. Next, L equal to 3 centimeter. Acha, tell me one thing. Instead of this, if some people says that a wire is wound on a cylindrical surface, the length of wire is 3 centimeter and area of cross section of wire is 4 centimeter square. The coil has 150 turns. Please tell me the inductance of the coil. So don't tell them any kind of answer, because tell them to give the correct data. Tell them to give the data of area of cross section of the coil and length of the coil. So AL is given. Next is number of turns given. It is 150. So what will happen? Value of inductance mu naught n square A by L. Here they have not mentioned any medium or any permeability. So what you have to take? You have to take 4 pi into 10 to the power minus 7 Henry per meter into area of cross section 4 centimeter square divided by 3 centimeter. Now centimeter, 1 centimeter square is cancelled. So from here it will become 4 pi into 10 to the power minus 7 into 4 by 3 into 4 by 3 into Henry per meter into centimeter. So now what is the meaning of centimeter? For centimeter you will have to convert into 10 to the power minus 2. So you will have to multiply by 10 to the power minus 2. So from here it is coming 0. L is coming 0.377 millihenry. 0.377 into 10 to the power minus 3 Henry. This will be the value of inductance of this inductor. I hope you enjoyed this session. Now if they give you any question based on temperature variation of resistance and inductance, means they ask you, either they ask you to find the value of inductance, or they are making some changes in the length or area or number of turns of the coil, then I think very easily you can answer that question. So thank you for attending the session. I hope you enjoyed the session. Next session I'll continue the same part, that is another part of basics of electrical elements.